Hey, in this video, we're going to have our first impression on virtual thread. And we will see how virtual thread can come handy for Spring Boot developers. Well, virtual thread has released in Java 21 version, and in my opinion, is one of the best features that has released after the Java 8 version. So in this video, I'm going to show you how the virtual thread works and why we should prefer it. And we're going to approach this as a beginner with all our understanding that we have with Spring Boot application development. So in this video, we're going to start simple and we're going to check what kind of problem that we have in a traditional Spring Boot application. Then we're going to analyze what kind of challenges that we face as a microservices dev. And then we're going to step into the world of virtual thread and we're going to see the need of a virtual thread. Right after that, I'm going to give you an introduction to virtual thread. And then I'm going to have a comparison with the virtual thread with the normal thread which exists in Java already, what we call the platform threads right now. We're going to have some real-time comparison between the virtual thread and the platform thread, and we're going to see who wins in terms of performance. So this is going to be a solid beginning for somebody who is already working on Spring Boot, but very new to virtual thread. Whatever understanding that you had on Tomcat as a server, where do you think it lacks?
Because it's blocking.
Is blocking. And what do you mean by that word blocking?
So, Vilas, the requests which are coming in Tomcat, those are actually concurrent requests.
Okay. So what's the issue?
Actually, thread is blocked until the response is not sent back to the user.
The thread is blocking. Yeah, I do understand that. But what is the issue we are facing if the thread is going to... So basically what I do understand, if I summarize all of your answer, Mahesh, Shashank, and Sovanik, what you guys are trying to explain me is that whenever there is a request coming, if we are doing any IOBound work, like any DB call or REST call, if you're making from our application, till the time we haven't get the response back from the third-party API call or the microservice call that we are making, till the time we haven't get the response, the thread is blocked. Okay. What will happen if a thread is going to be blocked, which is going to handle a user request? What is the issue?
Resources will be more it needs more resources then. If the number of requests are more, it needs more threads. Suppose if the threads are being shared, then it will be very easy. So whenever the thread is in in blocking state, it will be reused for other requests.
Correct. Basically, the end point is we cannot create so many threads. Is that the thing that you are saying?
Yes.
Because for each request, if we need to handle each incoming request, we need one thread, right? And if we are giving one thread to each request, okay, if that thread is getting blocked with some operation, what if there are multiple concurrent requests are coming? If there are thousands and millions of requests are coming, if we don't have that much threads available, because Tomcat works as a thread per request model, if we haven't have millions of threads available to handle millions of requests, then there will be a problem, right? Because the user's request will not be processed, because the threads, if the thread will be blocked for each user while doing some time-taking task, that will not be a good thing, because we cannot share the same thread to another request or another user to process their request, right? So that's the issue. Well, why can't we create so many threads? So what I understand is in Tomcat, where a lot of requests are coming, Tomcat has a server pool or a thread pool where we have some number of threads. And those threads are getting reused to process the request, right? But my question is, if there are millions of requests coming, why can't we create millions of threads to handle those millions of requests?
So it seems, Abhilash, it's a kind of heavyweight compared to processor thread versus this thread. It is lightweight, but we may need some lightweight compared to maybe it may use more resources like thread.
Exactly. The thread is creating a thread is not an easy job. Well, the Tomcat manage it for us, right? But in reality, thread creation is not an easy job. It just takes a lot of memory, right? In Java, when you create a thread, right? Imagine this is a thread. Whenever you create a thread, it's equal to, let's say this is your Java thread, right? This is your Java thread. This Java thread is equal to your operating system thread. Imagine if you have a OS thread, your Java thread is equal to the OS thread, or it has a 1:1 relationship. Now the problem is you cannot create a lot of OS thread. Okay, there is a certain limit how many OS thread you can create. Why? We will talk about this. But as I said, the Java thread is equal to OS thread. You cannot even create so many of Java threads like this. Okay, you can create few or certain number, but you cannot create so many of it. Why? Because one Java thread, to create one Java thread, there are a lot of things involved, like creating the thread, destroying the thread, and then the thread takes memory, right? Each thread takes memory. As I said previously, each thread can take 1 MB of memory. Okay, if one thread is taking 1 MB of memory, imagine if you are creating 1,000 thread, maybe it will create 10 GB of memory, right? So creating a thread is not efficient. Okay, you might say, okay, I don't care. If I have 1 million requests coming in my server pool, I will create 1 million threads like this. Then what's the problem? Well, you will argue with me that, okay, thread taking memory, right? I'll increase the memory. Okay. So right now, imagine this is my machine. If it is a Mac machine, it is allowing me to create 4,000 threads, for an example. Okay. 4,000 threads means I'll be able to, accept 4,000 incoming user requests. Let's say there are 10,000 user requests coming. Then you will say, okay, I'll create 10,000 threads over here. Then there will be a problem, right? Because your system will not allow you to create 10,000 threads in the first place, because each thread is equal to OS thread, as I said, and your operating system itself will not allow you to do that. Now the thing is, you will say, okay, I have money. So everything is right now hosted in cloud, right? You have a lot of cloud providers who are giving you machines where you are deploying your web application, right? You will say, okay, right now you are deploying in your Mac machine, which is your local machine, which is giving you around 4,000 threads. Okay. What about if I'll increase the RAM to 20 GB or 34 GB? Okay. If I'll have a 34 GB RAM, you can say it will allow me to create, let's say, 8,000 threads, for an example. Okay. Now, let's say if there will be more and more requests will be coming, I'll be keep on increasing this RAM. And if you're going to keep on, increase the memory over here, the people who are selling you virtual machines, they will be very, very happy. You will be their top one customer, right? And you don't have any problem, spending millions. So, they don't have any problem receiving your money, right? So it doesn't work like that. Otherwise, you will go bankrupt, right? So this is not a good solution if you are going to increase hardware just to create more and more threads, right? And I said all this thread takes memory. What kind of memory it takes? Anybody have any idea? Don't want to go so much depth of it. I said whenever you create a thread, it is a very costly operation because it takes a lot of memory. What kind of memory this thread takes? Anybody? A little bit?
So heap
Yeah. Any
memory?
Java object we create, it goes to heap. So objects are created in heap. But thread memory basically goes to heap or stack.
Right.
Yep.
Right.
Oh, it is stack, Abhilash. Sorry, it is stack.
Why it is stack? Why it is stack memory thread is using?
Because the multiple method calling and everything is there, right? Stack.
Yes. Correct. Because let's
Yes.
say you have a method called void main, okay, or void m1. Inside over here, you have 10, 20, 30 variables. All are int id, or imagine all the primitive variables that you have, long something, right? Whenever one thread is going to operate over this method, all these variables, where it will keep inside the stack memory, right? Inside the stack memory. Like that, if 10 threads will be created, all the 10 threads will be having their own stack size, right? That's what I'm saying. More and more thread will create, and more and more thread will operate over this method. They will need to store these variables, right? And where they will store? Inside the stack, right? So every thread will be needing a stack memory. Okay. Apart from that, also there are a lot of things involved. So let's not go into that. One takeaway with all this conversation is, the thread creation is costly. You cannot create so many threads. Well, before Java 17, I think, not 17. I think so. Before Java 16, I think, there used to be only one type of thread do exist. And that is called thread, right? When you say thread, when I say thread to any Java developer, they do understand, okay, thread means he's explaining a thread, right? Because you have understanding what is a thread means, right? But right now, when I say thread, people have so many thoughts about it because there are not one single type of thread available. There are two types of thread available. Okay, you know about this. One is called normal thread, what people call platform thread. So if you have ever studied multi-threading, ever created a thread in your life, that's the platform thread. Right now, the Java people are telling it. And there is one new type of threads has been created by the Java developer, and that's called the virtual thread. Okay. Now, when do we need to use virtual thread and when do we need to use platform thread? There's a topic, there's a debate, we'll talk about it. But right now you can think, whenever I'm telling creating a thread like this, okay, in Java application, you used to create threads. Even before Java 17 also used to create threads. Those threads right now, what we call platform thread, okay? So when we create a platform thread, is equal to a OS thread. There is a 1:1 relationship. You can think like that, okay? Here only you have JVM. Imagine if it is a Java thread, you are creating the thread on JVM, right? But it's a very thin layer. JVM thread means it's directly attached to the OS thread, okay? That is one thing. Well, one thing I told you, let's say if you have a Spring Boot application, we'll talk about this thing. We will come back to this thing. Why we can't create, one second, I'll write it down so that I will not forget it. Why we can't create so many threads, okay? I will prove this. I'll prove this, just one second. I'll have one question for you before we going forward. See guys, in a Spring Boot application, by default, how many threads are available? I told you last time. Anyone?
200.
200, correct. Okay, by default, there are 200 threads. So what do you mean by there are 200 threads? Like, can you just prove me with a use case? What will happen if there are 200 user requests will come at the same time? Then what will happen? Will you have any problem? Imagine 200 people are visiting to your website at the same time that you have written on Spring Boot.
At the same time, this request will not be handled because context switching will happen, right?
Context switching will happen. First of all, tell me, you have 200 threads in your Spring Boot application. Let's say this is your Spring Boot application. Now there are 200 requests coming. Whether all your requests will be handled by the web server. Do you have enough threads to handle?
Yes.
Yes, because 200 thread per request model. If there are 200 requests coming, you have 200 threads. So all the can be handled by the web server. Now, Sovanik was explaining that, and that's a very good point. Imagine you have one thread handling one user request, another thread handling another user request, another thread handling another user request. Like that, you have so many threads. Let's say this is thread 1, this is thread 2, this is thread 3. Like that, you have so many threads available. Okay, like we have thread 200. Okay, imagine this is another thread which is handling all this user request. That's fine. Let's say I'm on a Mac system right now. Okay, or let's say I'm going with a very older laptop or older server. Imagine that server has a CPU. Okay, and that CPU has 2 cores. This is one core, this is another core. Let's say it has a 2-core CPU. That means your Spring Boot application has deployed on a machine which has a 2-core CPU. Now, your Spring Boot application is accepting 200 requests like this. Okay. But all these 200 threads are working in the same time? No, they are not all executing in the same time. But the way it works, at a time, 2 core mean 2 threads can be handled, right? So this thread will be given to this core, this thread can be given to this core. Let's say they will execute for some time, they will execute for some time. Again, after some time, again, this will be given to this core, this will be given to this core. This will execute for some time, this will execute for some time. Again, this will be given to this core, this will be given to this core. This will execute for some time, this is execute for some time. Again, it will switch. Again, it will switch to this core, this thread. Again, it will switch to this thread, and this two will execute sometime. Let's say these two can execute at some time. These two can execute at some time. So there will be context switching will happen like this, right? Like, let's say all 30 of you are talking to me right now, or all 50 of you are talking to me, or let's say there are 100 people that are talking to me. Okay. Then I can say, let's say everybody is asking me some question. Sometime I'm responding to one guy, sometime I'm responding to another guy, sometime I'm responding to another guy, then coming to the first guy again, right? So I'm giving my time equally to everybody. For their question they're asking, I'm giving that person answer. So I'm giving time to everybody. So like that, the CPU, there are 2 cores only. At a time, only 2 threads can be executed, but this 2 core will give time to all these 200 threads, right? So sometime thread 1, sometime thread 2, sometime thread 3, which is handling the user request 3, sometime thread 4, which is handling the user request 4, sometime thread 200, which is handling the user request 200, then again switching back to the thread 1, which is handling the user request 1. Like that, if you see, right now you can think like, for all these 200 users, their request is being handled and they are getting response. But all their requests are not handled in the same time, right? So that's the main thing that you have to understand, what we call context switching, right? So, we have already spoke about this maybe in one of the, I think many of the video, parallel stream and all that videos are there. You can go ahead and can learn about it. Now coming back to our real question. In a normal application, guys, in a normal Spring Boot application, previously, right now virtual thread is a new thing. Previously, imagine if you're creating a Spring Boot application, okay, let's say it has 200 threads, okay? This is a Spring Boot application, it has 200 threads. That means, imagine if the 201 request will come, okay, then you don't have any thread left to handle the 200 first request because all the other threads are handling the rest of the 200 requests. In that case, one of the thread has to be free of. Like if one of the thread done processing one of the user requests, then it can accept the incoming request again and can proceed, right? So that's how the Spring Boot application works. And if no threads will be available, then this request will be rejected by the web server because we don't have any thread left to handle that request. Now I have a question for you because you guys are all microservices developer, right? I think most of you have done my microservices course and maybe some of you are doing it. Or you are already very experienced. So I think this is a very simple question you can answer. Now my question is, guys, if I'm working for a banking client, let's say, they are giving some high interest on some FD, okay? Let's say if you're going to create a FD or a fixed deposit, you will get 10% return, okay? Huge, right? In India, it's around 7%, 8% max. Let's say one banking client is saying, okay, I'm going to give you 10% return if you're going to create an account and save your money on that account during the next 30 days. That means there will be a huge traffic which will be coming into your banking application. But you have a Spring Boot application. Your code has been written in the Spring Boot application. Okay, and your Spring Boot application by default can handle 200 concurrent user requests. Let's say for now, it can handle 200 concurrent requests. For an example, we can stretch it, but let's say 200. In a normal, traditional, way, how are you going to be resolving this? Imagine you're going to be having 10,000 users will be coming to use, or you need a capacity for your application which can handle 10,000 user requests. So how you will be solving it as a Java developer or an architect? Like, any idea?
Load balancing.
Load balancing. Okay. So in the load balancing, how do you maintain the load? How do you balance the load? Yep.
Because we will have multiple instances of that particular service,
Mm-hmm.
and we have a load balancer. So based on some algorithm, it will work actually. But yeah,
Okay.
we have multiple instances.
Multiple instances. Multiple instances means, Sovanik, can you please simplify that for our users?
If we are talking about like maybe that particular microservice,
Mm-hmm.
that particular microservice will replicate.
Mm.
This is one option. And
Mm.
another is like I worked on like in Kubernetes. So there
Mm.
is something called horizontal pod auto scaling, right?
Horizontal scaling. Okay.
Yeah.
Okay. Great point. But we'll come into this a little later. But 1, 2, or 3 words you have said. Replicate, like you
Correct.
want to replicate the Spring Boot application. Like you have an application, you want to create 3 instances of it. What he means by that instances means he want to create 3 like same application, the copy of that same application. That's what Sovnik means. Let's say let's say you have your banking application, which is your Spring Boot application I'm writing. So for that, you'll create 3 copy. Let's say Spring Boot application 2, Spring Boot application 3 is the copy of the first application. This is the copy of this application in simple word. So that means here, if you're going to start this Spring Boot application and another server, you will also have 200 threads. Another Spring Boot application, you will also have 200 threads, right? So now, let's say if you have a banking application, the same banking applications right now running in 3 different server. Now what Sovanik was explaining, he'll put a load balancer over here. Whenever the request will come, some request will go to here, some request will go to here, some request will go to here. That means right now we have 200, 200, 200. 600 requests can be handled at the same time. Like that, we can scale up. That's what he was using, that word, horizontal scaling. So this is one way to fix it. You can keep on creating more and more copy of that thing and keep on deploying that one server. But again, the same thing, right? Like if you're going to create more and more servers and if you're going to create more and more copy of that application and keep on deploying in more and more servers, again, you need to purchase those servers, right? It will not come free. So again, money waste. Okay, obviously you need to give money because you are running a business. So you might argue with me that, but there is a thing called cost cutting. You cannot give all your money if you're running a business, right? Because you have to manage so many different things. But let's say in that case, you have all these servers you have deployed. And he also used a word called Kubernetes. That means, what he means by that, I will have horizontal scaling. What do you mean by that? That means whenever the load will come, then only I will, create a new copy of that particular application and deploy it on the server. If there are less load is coming, let's say right now, total 4, that means 800 concurrent requests I can handle. For an example, just to make it simple. So I have 4 things over here. Each thing have 200 threads. So 800 threads I have in total. So 800 concurrent requests I can handle right now. Let's say right now 200 is coming. So why do I need to deploy this many things? So I'll turn it off. I can turn it off. I can turn it off. And for that, we can use Kubernetes. Okay. So right now you have only one, application running over here. So it can handle right now 200 concurrent requests. Right now my request grows. Let's say it's 500. So maybe I can turn it on. I can turn it on. Right now I have 3 things. It can handle 600 requests. All these things can grow automatically. And that's the new feature. A lot of vendors are providing us that. We can use Kubernetes and all that in our real time. And that's again a solution. But again, you're wasting your resources over here, right? You are wasting your money on this. Now the thing is, the solution will be great if you have one application and here only you have no limit. Create threads as much you want. Create so many threads here, okay? Imagine you have one single thing and here you keep creating threads like this. And nobody is questioning you. For each incoming request, it is going to create one thread and going to assign it. For another incoming request, it is going to create another thread and going to assign it to that. For another incoming request, another thread will be created and it will assign to that. So in this case, it looks like it will be amazing if you're going to have something like this, right? As I said, like, if you have a lot of money, then you can spend it anywhere, right? You can spend it the way you want. But if you have very less money, then you have to be in a tight budget, right? So you have to look for different things before spending your money. It's just like that. Here, if you're gonna do something which can make the thread creation cheap, not costly, right? If we can make the thread creation cheap, and if this can be possible for each request, if we can create one thread to handle that request, this will be great, isn't it? We might not need all these things, right? Is it possible? And this is exactly what the virtual thread does, right? The virtual thread says, okay, so right now you are concerned about that 200 threads, let's say, that you have in the Spring Boot application to handle 200 user requests, right? Okay, I'm giving you a superpower right now. Okay, for each request, I'm going to help you to create a new thread. Okay, now this will be amazing. Now, how all this thing will work, right? And how I'm saying that it will be very easy to create all the virtual threads, and even our OS will not complain about it, right? Because in reality, all this thread creation will happen in the JVM label. And your OS thread, which is running behind the scene, will know nothing about it, right? So the thread creation will happen in the JVM label by the Java virtual machine, and the Java virtual machine help you to create millions of threads right now without letting the operating system thread knowing about it. Okay, and all these threads will right now run over this operating system thread behind the scene. And operating system thread have no idea that on top of it, so many threads are running what we are calling the fake threads or the virtual thread. It's not fake threads. It's actually going to do a lot of things, but it's the virtual thread. We're going to be creating the threads virtually, okay? Which actually doesn't exist in the operating system level, but in our Java virtual machine level, okay? So this can be a solution to our problem. If so many user requests are coming, we can have so many threads, and that will be great. So this things makes a little bit of sense, whatever I said. I haven't explained anything, but whatever I discussed so far, is that making sense to you guys?
At the core level,
Yes.
can you repeat once, if you don't mind, please?
In the code level, right?
Core level. Yeah, at the OS and JVM level.
Oh, yeah. Oh, 1 second. Let me just, because I haven't explained anything. For now, I have just told you one thing. But there are two types of thread I told you in Java right now. Okay. One is called platform thread. Okay. This is the platform thread. And one is called virtual thread. Okay. The platform threads are the normal thread that you already know. That means if you want to create a thread in Java, that is equal to the operating system thread. Okay. So the Java thread is equal to the OS thread. Okay. In case of platform thread. Okay. But whenever you talk about the virtual thread, so if you have this OS thread, imagine on top of this OS thread, let's say in your Java, let's say this is your OS thread. Okay. And let's say this is your platform thread. Okay. This is your platform thread or the normal thread that you create on Java. Okay. This is the platform thread. Now on top of this thread, you can actually create so many threads, right? And all these threads will run on top of your platform thread only, or on top of your, the thread that you basically create on Java. On top of that only, all these threads will run. And this is what we call the virtual thread. You can create so many threads and can assign it to your platform thread like this. Okay. And the operating system thread have no idea that all these threads are running. Okay. This is the only thing I told you. And as these are virtual threads, we can create so many threads right now like this and can assign it to our platform threads. Something like this. That's why I'm saying creation of these threads are very cheap. It's not costly, because if you want to create a platform thread, one platform thread is equal to one OS thread, right? But in virtual thread, one virtual thread is not equal to one OS thread. We can have millions of virtual thread right over here. Let's say right now your operating system is allowing you to create 10 threads. Your CPU core have only ability, or your CPU has only ability to create 10 threads, let's say, or 8 threads, something like this. Then on top of this 8 threads, you can create millions of threads like this. Okay. Something like this. Okay. And
If that platform thread takes, like, for suppose 1 MB space, so in that 1 MB only, we can create on top of it millions of threads.
Exactly. Let's just prove it. Let's just see that. Let's just see that right now. Okay. That will be more easy. Now, how that works, that's a different thing. We're going to be coming into that. Now, first, let's just see whatever we discussed. Can we prove it? Okay. Can we prove this? Actually, let's just see that. One second. Okay, guys. We guys are in sync, right? Did I confuse you guys? Whoever learning it for the first time.
No, Abhilash.
No.
Hey, here I need an honest answer. Otherwise, you guys will only get confused. I will not be suffering. Yeah, Gajanan?
No, Abhilash, no doubt.
No doubt, right?
No, not at all.
Okay, perfect. Now, let's just put it into practice. Okay, let's just see. Let's just analyze a bit. What time is it? Okay, it's 8:41 already. What did we speak? What I was doing for 40 minutes. Man. Okay, no problem. Okay, I'll not do much thing anyhow. Okay, imagine we have this application. Okay, so whatever application this is, don't bother about this application. Let me just create a class here. Okay, let's just say platform thread, or let's say thread example. So let's just understand whatever we have discussed so far. Can we prove this? Imagine you have a main method. Okay, imagine we have a method called public static void handle user request. You have this method. Okay, imagine you have some code over here which is going to help you to handle a user request. Okay, so if there will be 10 requests will come, then all the 10 requests will be executing this particular method. Okay, very simple. Imagine you have a simple method called handle user request. Okay, and I want to span up. I want to I want to create so many threads over here which can execute this particular method. Okay, so how can I do that in Java? Simple Java. So I have to create a thread, so a new thread, and it's gonna text a runnable, and I can use a little bit of lambda to override my run method, and I can just call this method called handle user request, something like this, and I can start my thread, and there you go. Okay, this is how I'm gonna start a thread, right? If I want to, create two threads, which is going to operate over this method. Imagine two requests are coming or two users are there. This is for the first user. Another user is coming. I can create another thread which will execute the same method. Okay, which is handle user request. Okay, for now, let's say I'm only going to create one thread. Okay, and here I'm going to log something. Let's say sys out starting thread. Okay, and I'm going to log the thread name. I'm going to say thread dot current thread. Okay, I'm going to print the thread, and here I'm going to say ending the thread. Okay, starting the thread and ending the thread. And let's just see that whether I'm able to start the thread and end the thread over here. Okay, and looks like I can do that. Okay, starting the thread, and this is the thread that I've created. The thread is thread 0. 5 is the thread priority, belongs to the main group. Okay, but this is the thread number. Okay, we have created the thread called thread 0. Okay, our main method starts. That means a main thread created, and the main thread actually started this thread and then exited. And this thread right now is basically performing this task. Okay, and this is what we call platform thread, right? This is what we call a normal thread in Java, right? And when you create a thread like this, this is equal to the OS thread. Okay, this means that you have created a new thread on Java, and this thread is 1:1 to your OS thread. That is the thing. And creating thread like this is going to be costly. Okay, and when you think like you have a Tomcat server which has a lot of threads, those threads are these threads. Okay, and this is what we call the platform thread. Your Tomcat thread is also equal to one platform thread. So you have to be very careful how many threads you can create. So for an example, for this, you can't create so many threads. Okay, let's just see if we can create, let's say this thing, I want to, let's say if I want to create 1,000 threads, then I have to copy and paste it like this, okay? Rather than, let's just run a loop here. Let's say for, say int I equal to 1, I less than equal to, let's say 100 threads I want to create. Let's just see whether my machine is allowing me to create 100 threads. Let's say I plus plus, and let's just wrap it off. Okay, something like this. Can I run this? Okay, starting the thread and ending the thread. Here, maybe here, I'm gonna put a sleep over here just to make sure it will be sleeping for some time. Go for 10,000 millisecond. Okay, wrap it off with a try and catch block. Okay, I'm doing nothing. So this looks a little messy, but bear me with that. I'm here, I'm just doing a sleep. I'm gonna start the thread, sleep for 10 seconds, then gonna end the thread. And I'm creating 100 threads like this. Let's just see what is going to happen. Okay, starting the thread, started around 100 threads over here. All these threads are waiting for 10 seconds right now. And then all the thread has been ended. Okay, so I think here you can see starting the thread is around 99. Yeah, so it's creating kind of 100 threads over here, isn't it? Look over here. It's creating all these threads. So 100 threads can be easily created. Okay. What about in my Mac machine? I'm using a Mac Mini right now, and it's having I think 16 GB of memory. Okay, so can I go up to 1000? Is it going to allow me to create 1000 threads? Let's just see. I think it is allowing me to create 1000 threads. It's actually 999 because of my for loop. Okay, and it's ending the thread. So I don't have any problem doing this. Okay, let's just start with 0. Okay, run this with 2000 thread, or let's just go with 3000. Let's just see whether we'll be able to create 3000 threads. I think we can with this machine. Yeah, we can create around 3000 threads. Okay, it's gonna take a break for 10 seconds. Yeah, it's ending it fine. What about 5000? Okay, I just want to see where it falls. And this Java application. Yeah, there you go. You can see right now it is failing maybe around 4065. Okay, it is not able to create this, and it's going out of memory. Let's just run this again. Okay, you can see out of memory error, cannot create the thread, possibly out of memory, and stack size is right now 2048 KB. And for each thread, that's the stack size, and it's only able to create the 4060 threads. Okay, so beyond that, the operating system only is not allowing me to create that thread. Okay, so we can go up to 4000 thread in this machine. As I said, okay, now if you want to say, okay, Avilas, go ahead and upgrade your machine, purchase some RAM and put it in your machine, then it will work for 8000 thread. Yeah, that's fine. But, I have to spend money on this, right? But why should I? I can go virtual, right? I can go with the virtual thread. I think my virtual thread will allow me to create millions of threads with this machine only, right? We're going to be proving this. But the thread creation, the platform thread creation that you are doing over here, you cannot do that for millions of thread because you don't have, your OS will not allow you to create that much of thread. Is that point make sense? Is this thing making sense, guys? Confirm me. Then I will go to the next thing.
Yes, Abhilash.
Yes.
Yes, Abhilash.
Okay, all
Yes,
good.
sir.
Everybody,
Yes.
you are in sync with me?
Yes,
In sync
yes.
with me, guys? Yeah, okay.
Yes.
Yeah.
All right. Okay, guys, before going to the next thing, I have a question for you, okay? Just for our foundation. Tell me, thread.sleep here. This is a CPU-bound operation or is it an IO-bound operation? Just asking.
CPUBound.
CPUBound.
CPU-bound. Why do you think it's CPU-bound? Okay, guys, who doesn't have any idea what is CPU-bound and what is IO-bound? Hold on, I'll explain. But yeah, why do you think it's a CPU-bound operation? Yeah. What do you
He's
think
doing
about
some other task.
it? Is doing
As,
some other task. What do you mean by CPU-bound and what do you mean by IO-bound? You already explained me about the IO-bound, but what do you mean by CPU-bound? And what do you mean by IO-bound? Anybody have any perfect answer?
So here interrupted exception is there, but if it is IOBound, this IO exception is there.
That is technical thing, Swati.
Yeah,
Explain me in layman term.
Yeah.
because here CPU.
Yeah.
Here CPU.
operations.
One
CPU
by
has
one.
Yeah.
Yes, CPU has suspended the operation for this thread.
Perfect. That's the right answer. Your CPU has suspended the operation because of this sleep. CPU will be parking the thread. Whatever the thread that you are creating over here, the thread will be parked, right? That will not do anything for 10 seconds. That means it's kind of blocked. That thread is waiting for that 10 second to over. And then it will start again, right? So I can say this is a IO-bound operation. It's not a CPU-bound operation. Well, I'll just give you a little bit of example. Okay, I'll comment this out. Okay, forget about this. You have two lines, starting the thread, ending the thread. Okay, here I'm gonna do for, okay, let's say I have a variable called int sum is equal to 0. And for each operation, I'm gonna do sum is equal to sum plus I, right? Don't understand the logic, don't give a damn about it. My question is, if I'm going to run this, let's say sysout sum. Okay, forget about this logic. Okay, if don't give a damn, I just typed it randomly. Now think like there is some calculation is going on, some mathematical calculation. And if I'm going to run this, yep, a lot of things are happening here. And it's calculating something, and all of these threads are starting and calculating. Yeah, there is some mixed result you are seeing over here in the sphere because multi-threading. Some thread is starting and doing some task. Whoever ends fast, that is ending. Then some other thread is starting. Yes, there is a mixed output. But yeah, the problem statement here, we're creating 5,000 threads. Okay, all the threads will not be created, I think. So let's just say we're creating 3,000 threads over here, okay? And for 3,000 threads are doing this work. Each thread is doing this mathematical operation and printing the result, okay? So there are 3,000 threads. So all the 3,000 thread will execute this method, gonna run this code, and gonna print the result of it. Now tell me, this is an IO-bound or is it CPU-bound?
CPU-bound.
CPU-bound. Why do you think it's a CPU-bound?
Because the processing is happening, right? The calculating the sum, mathematical operation is happening here.
Perfect, Sovnik, you're right on point. Whenever you guys see any loop, okay, that's CPU bound. Whenever you see any kind of long running task is happening in the CPU only, in your code only if it is happening, right? You are not dependent on something else. You are not making a network call. You are not making, how can I tell you that? You are not making any DB call. Okay, you are not connecting to any other website to make the handshake happen between that website. Till that time, the thread will be blocked. No, it's not happening like that. So here, imagine guys, as I said, you have CPU. Okay, CPU means you understand, right? Inside that CPU, we have a chip. In that chip, you have core, right? Let's say there are 2 core CPU. That means it has 2 cores. So how many threads can be executed at the same time? You know that, 2 threads. Parallelly, only 2 threads can be available, can be executed. But if you have more threads, then there will be context switching will happen between them. Here, the question that I have asked, imagine I have threads like this. I have 2,000 threads, right? Now, for all these 2,000 threads, what is happening, right? They all are doing some calculation. This is also doing some calculation. They all are doing some calculation only, right? So let's say CPU, this thread, imagine this is just like your maid. I should not say that. This is just like a chef in a hotel. Okay. The CPU, imagine this is just like a chef in a hotel. Okay. The work of this CPU is just to cook. He always want to cook because you are giving salary to the chef just to cook, right? You don't want the chef to sit idle and listen to some songs or scrolling his mobile, right? So what you want, you always want to assign some thread to this CPU core. Okay. Let's say this thread you are assigning, this thread you are assigning. That means this thread, imagine this thread, they all are doing some calculation that is happening over here. Imagine this is the for loop. So the CPU core will be keep on doing the task, keep on doing this calculation, and it's going to be busy doing that work. So this is a CPU bound task. Let's say maybe after some time, again, this will be given to this, this will be given to this. Then this will be given to this, this will be given to this. Then this will be given to this, then this will be given to this. Then there will be switching happen. But in every moment, this chef is cooking. this CPU is working. The CPU is computing this code. Okay, so the CPU is busy. That's why this is what we call the CPU-bound task. So the CPU-bound task means, as I think Sovanik was explaining and Chinmoy was explaining, this does mean that you are making the CPU busy, right? Right over here. That's why what we call is a CPU-bound work, right? Your core is busy processing or calculating this mathematical operation. Hope this makes sense. Now, instead of this, if we're going to do this, then what you are doing? You are starting the thread, then blocking it. That means it's going to slip. The thread will not do any work. If the thread will not do any work, it is going to sit idle. It is going to wait till this 1000 second to end. And your CPU will not do anything because the thread is only it's just blocked, right? So what your CPU will do, it is also going to go ideal because the thread is not working, right? So the CPU, you're wasting your CPU. You're wasting your CPU core. It's not executing, right? So that is the problem actually we need to solve, okay? So if you're going to see, imagine here you're writing some code, call to some service, okay? Call to microservice, okay? Or call to any REST application you are doing over here, okay? And you are expecting for a response over here. You are expecting for a response, okay? Then you are calling to some DB, okay? Call to DB, okay? Then you are expecting for response. Now this is what we call IOBound call, right? You are making this call, then sitting idle, okay? Waiting for the response. You are calling to the DB, then sitting idle, waiting for the response. That means the thread which is going to handle this request, that's just going to be blocked, right? So imagine it's going to be something like this. This is a thread, okay? Now the thread has been start here, okay? Imagine the thread ends over here. Now it started, okay? This is a print, it just printed it. Now it's making a microservices call, okay? Now it's make the microservices call here. Imagine after that, it is going to block. Imagine it is blocked till this. Till that time, the thread is not doing anything. Then again, right over here, you got the response, okay? Again, you make the call, okay? Then again, you're calling to DB, the DB is executing. Then again, the thread is not going to do anything. It is going to block, okay? And then after some time, you got the response and you're printing this and you're terminating it, right? Now you think, imagine this red bar. So this much time is my running time, okay? And here, let's say it's run for this much time, then again blocked, then again it's run for this much time. Now this line, okay? This is where your thread is blocking, okay? Your thread is not doing anything. It's just sitting idle, right? You don't need to make that happen, right? You do not want this part, okay? If you consider this as a total running time of your thread, see how much time your thread ran and how much time it's just waited. It's just blocked. It's not doing anything, okay? And if a thread doesn't do anything, right, it's just going to sit idle. And if it is a platform thread, which is very costly to create, then obviously you're going to suffer. You have to spend money then, right? And that is the point that we need to solve. And that is the problem we'll be solving through virtual threads.
Yes, I have one doubt actually. We'll be creating the virtual thread as you are mentioning about virtual thread. So will it work independently? Like there will be no relation, like normal thread as whenever we are working in normal, there will be no relation, right? So
no, there will be relation. There will be relation, but that is what the thing you need to understand. Internally, as I said, see, I don't want to confuse you by dragging this thing right now. But one thing you know, Sovnik, I told you one thing, no? Virtual thread works on top of the platform thread.
Correct.
So there is a relationship. How that is working, that's a different thing. We need to see, right? We need to understand that thing. But as the virtual thread is created upon the platform thread, and as the platform thread is directly related to the OS thread, internally, you know, if you're gonna your platform thread is blocking. Your virtual thread is blocking internally, but it works in a certain way that it seems like non-blocking and people are very fancy about it. They are like, okay, it's just doing some magic. It's actually doing the magic. And for that, we need to understand how it works. And it's very simple. It's just 5 minutes discussion. Maybe we're going to talk about that in the next lesson. So your question will be answered like once you understand how the virtual thread works internally. But let's come back from there.
Okay.
One thing I want to highlight over here, this kind of operation, which are your IOBound operation, which can block the thread. In a method like handle user request, which is doing some IOBound operation, in that kind of scenario, virtual thread can be massive. It can be like a shining star for you, right? It can only help you when there will be some IOBound operation. Okay, it might not help you more whenever you are just talking about CPUBound operation. Okay, I think this is going to confuse you, but we'll come back to that. But why? But I can prove you why. Okay, but for that, we have written some code previously, right? Let's just bring that in. Okay, this is the IOBound operation. Now you guys know that because this is blocking. Okay, now right now, if I'm going to create 4,000, let's say 5,000 thread platform thread, am I able to create in this machine? This is the normal thread, right? I'm not able to create. I'm getting an out of memory error, right? Now, can I create 5,000 virtual thread? Easy. You definitely can create 5,000 virtual thread because this is not that resource heavy. It's not that costly. And how to create a virtual thread? And guys, trust me, if you're going to watch it for the first time, it's the same thing, okay? Instead of stat here, you just use stat virtual. Stat means you're starting a platform thread, okay? You just need to use stat virtual. But see, I'm not getting it. If I'm not getting it, that means I'm using Java 17. And in the Java 17, the virtual thread was not present. It introduced with Java 21. Now, one more point over here. In Java 17 also you can use it, but as a preview feature. It came as a preview feature. So for that, you have to use the OpenJDK, Project Loom and all that. So we will not go into that because right now we are recording it in 2025, in the end of 2025. So we already have Java 21 available, right? So I just need to switch the build path. So configure build path. Here, instead of that, can I add one more JRE? Add library. Okay, JRE. So whenever you're creating the project, create it using Java 21. Okay. So if you are not getting it, just click on this install JRE section while you're practicing. If you have a other thing, and then add the 21, just like this. Add. Then maybe the JRE you will get over here. Then add the JRE and select the path. Okay. Now I have chosen 21 over here. So Java 21 is here and apply, close. And right now I got Java 21 JRE system library. And also for this Spring Boot project, here also I think the Java version is 17. Let's just change it to 21. There you go. Can I just do a map and update? Okay, I think it's all 21. Now let's just try to use start virtual. Runnable task. And you don't need to give the runnable task in the thread parameter, Control X. Put it over here inside the method. And there you go, you are done. Okay, you'll be creating 5,000 virtual threads right now. This is the way to create a virtual thread. But you're getting a warning because the start virtual thread is a static method. So you don't have to create the object of the thread. Okay, so you can just use class name dot start virtual thread. And this is, by the way, one way of creating virtual thread. There are so many other different ways, but this is one way of creating virtual thread. Just do this. Okay, now I'm going to do it for 5,000 times. Okay, and let's just see whether I'm able to create 5,000 threads. Okay, and there you go. A lot of threads are getting created, but is it actually 5,000? I can see up to 3424, and I can see. Okay, I am not able to see all the 5,000 threads. So what might be the problem? But I told you we can create 5,000 threads. And I actually did like we can absolutely create 5,000 threads. But here I'm not able to see on my console. So what might be the cause? Can anybody explain me this? Why I'm not able to create, or like what might be the cause? So I'm not seeing all the 5,000 virtual threads. Anyone?
Maybe we are reusing the threads. Like, I'm not sure.
But as I said, we can create individual thread, like 5,000 individual threads. I'm trying to do that. But this line will create one virtual thread. I'm doing it for 5,000 times, then I'll be able to create 5,000 virtual threads, right? Rakesh, have answer for this?
The thread 3824 having more worker threads.
Do you guys know what is a daemon thread? You guys know what is a daemon thread? It's the background thread.
thread.
Forget about that if you don't understand much about daemon thread right now. But right now, what is happening? My main thread is ending after starting this, right? So the virtual thread are the daemon threads. So when the main ends, I think this is terminating. Okay, it's not like doing the task. Once the main end, whatever the thread created, like that far, it is just creating that many, and then it's not creating after that. The program is getting terminated. You can see now my application is not running, right? So because I also have a sleep over here, but I'm not able to see the sleep statement and the ending thread statements. So what I can do actually, I can hang in for a bit. Maybe what if I'm gonna hang my main thread? I'm gonna say thread and dot sleep. Let's say here I'm waiting for 10,000 millisecond. That means 10 seconds. Let's just wait for 15 seconds over here. Let's just see what is going to happen. Okay. So I'm giving a sleep, running this again. Okay, starting the thread, my program is alive. Okay, I think the virtual threads are created. You can see the numbers and yeah, it's ending, right? So I can also see the number, but it's going beyond 5,000. I think it's going beyond 5,007. Okay, so how can we count all the virtual thread number? Maybe I can use something called a atomic integer. One second, just to count. But this is one thing you understand that I'm able to create 5,000 virtual thread. Okay, so can I create 10,000? Okay, can I create 1 lakh? Can I create 1 million over here? Let's just check. Can we create 1 million? Let's just remove the sleep time. Otherwise, it will wait for a lot of time and for 1 million thread. If you're gonna wait for that much of time, it will be huge, right? But let's just try to create this much. Wow. See, no memory error. How many virtual threads you want to create? How many threads you want to create to handle your user request? There you go, right? In a Spring Boot application, just write one line of code and you will be able to create, millions of threads, right? So this is how the virtual thread can help, right? Okay, I want to count the number, whether I'm actually able to create that many threads, because only looking into the log, it is not proving that I'm actually able to create that many threads, okay? So what I'm gonna do, okay, let's just start with 1,000, okay? And here, what I'm gonna do, here I'm handling the request, right? Here I'm actually handling the request, starting the thread, ending the thread, waiting for some time. Okay, this is what I'm doing. I'm gonna create an atomic integer. Let's say atomic integer. This is just for the count. Let's say thread count. Okay, is equal to new atomic integer, and each time this method will be called, I'm gonna increment this. So there is a method thread count dot. What is that? Maybe this, I'm gonna make it a static, okay? Because this is also a static method. So thread count dot add and get, or increment and get, okay? This will be good. This is gonna give you an integer back. For every time this method will be called, there will be an incrementation will happen and will be assigned to this. So this is going to be my count. So maybe what I'm gonna do, I'm gonna add the count over here, like this. Okay, there you go. I'm gonna paste the count over here just to check how many threads I'm creating and ending the thread. And here also I'm just adding the thread number, okay, the count number, okay. And at last, also I want to log the complete thread count, okay, thread count, okay. Let's just check if we are able to create 5,000 threads, okay, because we are normal thread, normal platform thread, we are not able to do. So here, let's just see. Okay, ending threads. I think it's gonna end everything and then it's going to print. It's going to print after the sleep ends. And here we're giving a sleep per 15,000 millisecond. That means 15 seconds. And here you go. You have 5,001 thread created. And we have started from 0, gone up to 5,000. So it's 5,001 thread that we have created. And that we cannot do with the platform thread. We have already proved it, right? So see, you can go beyond 5,000. Let's just go with 1 lakh thread. Okay, can we do this? Okay, after 15,000, and see how fast it is. See how fast it is, how quickly it is creating the thread for you, right? In the normal platform thread, whenever you create a thread, there are a lot of process involved. But with virtual thread, it's very, very quick. It's fast. And you can actually differentiate whenever you're creating a platform thread, it's going to take you a bit of time. But whenever you're creating virtual thread, it's going to be quick enough to create. And you actually can feel that whenever you're doing any IOBound operation. It's very simple. I don't give a damn if you understand the code or not. The concept you understand so far?
Yes, Abhilash.
Yes, Abhilash.
Yes, Abhilash.
Okay, do you want me to prove, the virtual thread is faster than the platform thread, particularly whenever you're doing IOBound operation?
Abhilash, one question here.
Yes.
The thing, if we are increasing virtual threads here, right? For each request, one thread works, suppose. But coming to heap space, right? If all threads are working, the space will be consumed. If the, the configuration of the machine is remains same, if suppose, then how does heap memory will be handled?
Exactly. And here for the memory perspective, if you are thinking, Sunil, just remember the other statement that I've given. It's very cheap. It's very cheap. How the memory will be managed, that's how the virtual thread works internally. But is it going to take same memory as the platform thread? No. No. It is going to be very cheap, and the virtual threads are lightweight. All right, so before we go further, I want to do a little correction here. So if you're going to see, I'm having a try and catch block and this sleep over here, and all this thing that I'm doing over here inside this main method just to make sure my main thread is alive, okay? So this is not actually a good thing because I'm waiting for 15,000 millisecond, that's 15 second, which is not necessary. So what we can do over here in order to make sure the main thread is not dead and is still waiting. So we do not want to terminate the main thread right over here, because if the main thread terminates, our virtual thread, as they are daemon threads, they will be also be terminated. So now, because if you're gonna run this, okay, see the main thread terminates and only we're able to create this many threads, 19,137, but we wanted to create this many threads, right? So the virtual threads are daemon threads, so we need to hold over here. There are a lot of ways. You need to use thread.join. You can just join the main thread with all these threads that you are creating so that the main thread can wait till all this thread complete their execution. Or maybe I'm going to be using a simple approach. Basically, there's a countdown latch. If you don't know more about the countdown latch, don't worry about it. It's just a very simple line of code. I'm going to be using the countdown latch over here just to make sure my main thread waits till all these threads got created, and all these threads will perform this work. And after completing all this work, like my main thread can terminate. And till then, the main thread need to wait. Okay, and to implement that, I have removed the thread.sleep. If you are very confused with this, you can go with the thread.sleep, but I can go with a countdown latch. So countdown latch is equal to a new countdown latch. So very simple. So it's going to ask me for the counter, right? How many threads that I'll be processing over here. So that will be this many threads. So I'll have another variable called int thread count. Okay. And this thread count is right now is this much. And I'm going to initialize my thread count with this much. Okay. Now what I'm going to do each time, so I have a latch right now, which is initialized to 1 lakh, right? So each time a thread will be starting and completing its work, what I'm going to do, I'm going to do thread countdown latch dot count down. So it will be down by -1, then -1, then -1. And we will be keep on waiting till the countdown latch will be 0. But one thing that I need to check over here, I've started with 0. So this will be +1, right? So otherwise I'll just start at 1 so that I'll be having this many threads, right? So there you go. So I have a countdown latch of this many, number. And each time I'm going to be starting a thread, I'm going to be counting it down, okay? And over here, I'm going to use this countdown latch to wait, okay? So I'm going to do .await. And this will make sure what is happening over here. Just throw it over here. So over here, I'm waiting. The main thread is waiting till all this thread will complete their execution. So the thread will be started, will be performing their task. And once every thread is completed performing their task, then only the main will return and then it's going to print the thread count. Okay. Now let's just run this and let's just check. Okay. Let's see how many threads we are able to create over here. Yeah, so you can see over here the thread count. Okay, so it's exactly same as this, right? So that's pretty much it. So we're good to go with this. So this is just to do a little bit of tweaks just to make sure all our virtual threads are getting executed. And the thing is, we are able to create this many threads, and that's the big thing. Now, the next thing that I want to show you that the virtual thread are actually faster than the platform thread because the virtual threads are cheap, are lightweight, not resource heavy like the platform threads. How can I prove you that? So let's just do some operation over here. Here we are sleeping for 1000 millisecond. Let's say 10,000 millisecond. Let's just do one thing. Here I'm creating my virtual thread, okay? And I'm performing, my virtual thread is performing the handle user request, which is this task. And in this task, I'm not doing anything actually. I'm just waiting for 10,000 milliseconds. This is just like an IOBound operation. This is just blocking the thread. And I said virtual thread is best for IOBound operation. Like why I did tell you that, let's just prove it. Now let's just try to calculate to create 1 lakh or 1 million virtual thread. And if all the 1 million virtual thread will execute this method, how much time it is going to take. And let's just compare the same with the platform thread, okay? I think in the platform thread, in the first case, we will not be able to create 1 million thread, okay? So this is pointless if we're gonna test it with 1 million. But we have seen in this machine, we are able to create around 4,000 thread. So I'll go with the count 4,000, okay? Now let's just create 4,000 virtual thread, okay? Right over here. Execute this method called handle user request right over here. And let's just check how much time it takes. So what I'm going to do before I start the virtual thread right over here, before the for loop, I'm going to log the time. So current time in millis, right? And I'm going to log the end time as well right over here. Okay. Here we will log the start time. We're going to create 4,000 virtual thread and then we're going to log the time. And we're going to see how much time it takes, to start 4,000 virtual thread. Well, one mistake I did over here, I'm starting the virtual thread over here and I'm doing the last countdown over here. I don't want to do the countdown here. I want to do the countdown here inside this run method that I'm writing. I'm going to wrap this off with a curly brace like this. I'm going to give my semicolon here and I'm going to break this line, okay? I'm going to break this line. And I'm going to move this countdown latch to here. Sorry. Here only I have to do countdown. After starting one virtual thread, I have to decrement the countdown latch and I have to do -1 and it will be keep on going till it will be 0. Okay. So that's how, till that much I have to wait over here until it's 0. Okay. Until all the thread performs the execution because here I'm starting the thread and doing the countdown. So here we will wait all the thread that we have started over here. They should complete performing their work in order to make this code return. Otherwise, we will be keep on waiting over here. All the threads that we have started over here, they need to complete. Okay. That's why I've used the countdown latch and I have given the wait over here. Okay. So that's pretty much okay. So I have the start time, I have the end time. So I just need to log it. So maybe after all the threads complete their execution, I'm going to do another sysout, total time taken, and I'm going to do a minus end time minus start time. There you go. And this many millisecond. Okay. There you go. So let's just check like how much time it takes, to create 4,000 virtual threads over here and performing our handle user request. So let's just go here and run this as Java application, starting all the threads. I think after that, it need to wait for some time because there is a thread.sleep over here. That's what it is doing, waiting for 10 milliseconds. And then it's going to end everything. And once everything is ended, we'll be able to print the number over here. So let's just wait till all the thread executed. And we're going to be calculating the time. My application is still running, as you can see. Oh, sorry. There is a mistake that we have done over here. Here we have taken thread count as 1 lakh. So the countdown is not getting 0, right? The thread count will be this much. Let's just run this again. We are creating 4,000 threads here, which are the virtual threads. Yep. You can see the total time taken is 20 milliseconds and the total number of threads that we have created is 4,000 threads, which is good. So 20 milliseconds has been taken for virtual thread. Okay. For virtual thread is 20 milliseconds. Now let's just do one thing. I'm going to copy this and I'm going to comment this. Let's just create 4,000 platform thread. So instead of thread, I'm going to do new thread. Okay. And instead of start virtual thread, I'm going to just say start. And this run method, whatever I have written, I'll do Control X and I'll put it inside this thread. Okay. So now this is a platform thread, which is going to run it for 4,000 times. Okay. So we will be creating 4,000 platform threads right now. And let's just measure their time. Okay. So 4,000 thread. Okay, ending it, and it took 296 milliseconds. There we go. So the platform thread creation taken 296 milliseconds over here, and you can see there's a huge difference. Okay, can we run this again just to see if after warm up, if it can give us a better result? Let's just check that. We are rerunning the same thing, and this time it took 316 milliseconds. Okay, now if you're gonna uncomment this and create virtual thread over here right now and execute the same task. Okay, this is the IOBound task, remember, that we are doing over here, thread.sleep we are doing. So for an IOBound task to complete, it's just taking 21 milliseconds. It's a significant difference. And if you want to do some real testing, instead of this thread.sleep, if you want to do some real network call, maybe you can also try that. For an example, here I can connect to google.com and let's just see how much time it takes for my application to connect to google.com. Because if I'm going to make a request to google.com, then my application need to connect to google.com server, and my application and google.com server need to have a handshake. Until the handshake happens, the thread which will be executing this method will be blocked. Okay, let's just try that. So maybe I'm going to go with a socket. So I'm going to do socket is equal to new socket. So socket is equal to new socket. And I'm going to create a new socket with a address. So the address will be www.google.com. The port number here, I'll be open it up on a port number 80. And instead of socket, I can also use var over here just to make sure the things are a little bit looking simpler. And this socket I want to close as well. So I'll be using the try with resources approach like this. And I'm going to be wrapping it off with a try and catch. Okay, like this. And I think I'm good to go. I'm connecting to google.com on the port number 80, and till the time this method will connect to the google.com, the thread which will be handling that particular method, that will be blocked till the time we will have a handshake with the google.com. And once the handshake is over, I can just write sysout and connect it to Google. Okay. Now let's just test it with 4,000 threads. Okay. Now, first of all, let's just test this with the platform thread. Okay. Let's just comment the virtual thread. Okay. let's just create 4,000 platform threads, and let's just test how much time they will take to execute this handle user request method. Okay, connected to Google, connected to Google. Okay, so that's looking good. All right. I think my threads have completed their work. I will see the time right now. I think they are not yet over. They are still doing some task. They're still ending some thread. I can see ending thread 27, ending thread 3966. It's taking a lot of time because, it's all platform threads. We are creating one thread to do each thing. You can see it's still running. What's the final result? There you go. It took 330 milliseconds. There we go. It took 330 milliseconds for the platform thread. Okay. Now let's just do the same thing with the virtual thread. Okay. Run this Java application. Let's see how much time my virtual thread takes to complete all this blocking operation. That socket is actually a blocking operation. That's an IOBound operation. As I say, till the time the handshake will not happen, my thread will block. So let's see the final result over here with the virtual thread. There you go. It just took 22 milliseconds. So it's blazing fast. It's just like a flash. So this is how the virtual thread works. And this is why I'm saying the virtual thread is way faster than the platform thread. Okay, there are not much of resources is taking to create a virtual thread. We can create millions of threads. If you want, you can go ahead and create 1 lakh virtual thread and can do the same thing. And it will do it happily. And with the platform thread, your system will crash. You'll not be able to create 1 lakh platform thread in order to execute this thing. Okay, so that's how the magic is done by virtual thread. But how? And how it is doing that magic? That is going to be the discussion for the next session. Okay, so that's it. So come back to the next session. We'll talk about how the virtual thread works internally and how we can implement virtual thread with our Spring Boot application. And then we can proceed further and we'll compare it to Niti server. Okay, so I'll see you guys in the next session. Hope you enjoyed this session. And if you like this session, just make sure to give me a like and comment your feedback in the comment section, and also share this video with your friends if you do think it is useful. Okay, so I'll see you guys in the next video. Till then, bye bye, take care, and happy coding. Practice this. Subscribe.